Well, good evening. Here we are again, 2 weeks after the last one. I think this is probably a little loud. A lot of people on here tonight. I can't see everyone. I see Shane and Stacy and Peter and a few other people. I've tried to say hi to you before, but once I get going like this, I can't type in the chat. It's just too much. I have to do all my own video switching and everything else also. So before I do anything else, I want to remind everyone to subscribe. I probably need to squeeze this a little bit. There we go. Subscribe to us, and if you press subscribe like this, a bell will show up, and then you can press the bell, and that will allow you to be notified when we announce future videos. I'm going to try to do these every 2 weeks, but we have a trip coming up and some other things, so there may be 3 weeks between a couple of them, but we'll keep up a regular schedule anyway. Okay, so with that piece of info taken care of, yes, unsubscribe again. I wanted to show you a picture that came in yesterday from a new observatory that was put in up at Sierra Remote, where this is an Astro-Imaging video. So I thought I'd start by showing the results of Eric that he did a really beautiful image, Eric Coles. Just let me get that on here. And the best I can do, I don't have a really good image viewer, but check this thing out. And it's just his JPEG. It's actually kind of more amazing than that. Let me get this, see if I can get a better job here. Anyway, this is VDB152, and he told me it's about 20 hours worth of data that he's collected. It's a brand new PlaneWave L500 mount, the new L-shaped mount on a wedge at Sierra Remote. So I thought this was pretty good. In fact, it's quite impressive. I really, it's amazing. So with that, I should also mention that yesterday I did release the ACP Scheduler 8.1.1, which is really a field test for 8.2. If you are a scheduler person, and we're not going to talk about scheduler, by the way, in this video at all. Once I got it to detailing what we're going to talk about, I don't have time. So that's going to be for the next time, Astro-Imaging with scheduler. But anyway, it is a field test. Go to the Comm Center and read about it. And there's a download link there and everything. So if you're interested to test it, that's fine. If you have critical needs and can't afford to be taken down, don't test it, please. So with that little announcement, I need to mention remote observatories. This is really what ACP is the strongest compared to the other software out there is for remote observing. But as we're going to see in this video, doing it the old-fashioned way, it works. It has a lot of features that some of the other stuff doesn't have. So with that, I am going to try to explain just a little bit about how ACP works. And to do that, I will go here. I don't know if you can see this. Let me see if I can bump this up. This is a little bit crude. I'm sorry. I just kind of ran out of time to do this with the OBS. I'll do better on the other windows. I have sources for everything else, but the videos. So let me just go through a little bit about how ACP works. I know a lot of you already know this stuff, but to put things into perspective, I want to spend a minute or two just explaining what an observing plan is and how it fits into the picture. So an observing plan is a text document. That's it. It's just straight text. And it doesn't have programming in it. It just has declarative stuff. It says what you want to do, not how. There's no slew to here, when finished, do this, do that. It's the images need to be this big. The filter needs to be this. It needs to have a position angle of this. Target name, coordinates, boom, that's it. And all of the procedural stuff is handled inside this observing engine here. So an observing plan is a declarative, simple text document. You can make them with Notepad. We're going to do that tonight. We're also going to make them with Planner, but you can write them up. The simplest one can be like 5 lines long, and we're going to do that. Or you can use the web browser interface and build the observing plans that way. So you have a lot of different ways, but it's always just a text document. Simple, straight ASCII text document. ACP interprets it. First it compiles it, interprets it, goes off, grabs the images, puts them out on the disk, or maybe syncs them via Dropbox if you have that set up. As I say, you can use Notepad or ACP Planner to produce the plans, or you can come in on the web server, use the forms to produce the plans, and then hand the plans to the observing engine. So I hope that makes sense. Okay, let's do a simple task here. This is going to take me a minute to get set up to bring these pieces out onto the desktop. This one here, this is what you would typically run in the observatory. Focus Max. Actually, you know what? I'm going to leave that hidden. It's not that important. And then bring out a text editor, which is here. So doing things the old-fashioned way. Right now, let me just get an idea here. Right now, our local sidereal time is 17 hours. And so if I want to take an image of something a couple of hours to the east of that, this 17 hours, by the way, is the local sidereal time is the RA, right ascension of the meridian. So if I want to go 2 hours east, I add 2 hours to the 17, and that would be my RA coordinate. And then we'll use 50 degrees for deck. We're at about 34 degrees, so that's kind of north and high. So a typical ACP plan, I'm just going to build one here, and we're going to run it, and you'll see how easy this is. The interval, that would be the exposure interval, 300 seconds. And we could put binning in here, and I'm going to show you where to find out all the stuff you can put in here. But this is the simplest. Well, you leave it binning 1, and filter, red, that's one of my filters. Position angle, this observatory, sorry, I know I bumped that sound real high just then. This observatory has a rotator in it, so I need to tell it the PA. So on a rotated system, you have 3 coordinates, RA, deck, and position angle. It's a 3-axis system. We're going to get into that later on in detail and see how to set all that stuff up so that you always get a guide star. But right now, I just want you to know you have to tell it what position angle. We're just going to say 0 degrees, just a straight north up image. And we'll name the image the video nebula, whatever you want to name. Now here, if you're writing it yourself, you need to hit a tab, the tab key. And this, what did I say? 17, 21, 17, 20 degrees and, well, yeah, I mean 20 hours, 10 minutes, and then another tab and 50 deck. That's good enough. You could put 50 foo, it's real open about the format here. So 50.12345 will work also. That's an ACP observing plan right there. The interval, the filter, position angle. I could put binning and a bunch of other stuff in there, but that's about as simple as it gets. Where do we save it? We save it in My Documents. My Documents, ACP Astronomy Plans. And I'm going to put this in here as a video test. There's so many plans in here, or just a video.txt. All right. So there's our plan. We've saved it to disk. So now we have to load the Acquire Images script. This is all how the old-fashioned way. And I'm showing you this because I'm going to try, as always, to steer you towards using the web interface. But I'm showing this because this kind of gives you an idea of the machinery that's going on in the background when all this happens. So Here's the Acquire Images script. This is the observing logic, the whole thing. All of the logic for doing the observing is in the Acquire Images script. So when you run it, the first thing it asks you for is the plan. And our plan was a video. Here, there it is. Open it, and off it goes. Now, I know you can't see this very well. I just ran out of time to get a closer view of it for you. Actually, I wonder how I could do this. Wait a minute. There may be a way to get this to tighten up. Let's see. No, never mind. I'm not going to try to do the scenes here. All right, it's now acquiring the data. You can see the flashing exposure light up here. The track light is on. There's our pointing exposure. It's going to plate solve that now to get the image, how well the telescope's pointed. It'll jog the telescope and sync it. Sync and jog the telescope if necessary. And now it's going to go off and start the final exposure, 300 seconds. This will complete a lot quicker than 300 seconds because I'm using the simulated images feature, and that speeds the time up by 10 to 1. We're not going to sit here for 5 minutes while it exposes. It's just going to take 30 seconds instead of 300. So while it's doing that, this is basically the simplest ACP plan you can make. I think I'll get on to the chat window again so I can see your questions in a minute, but that's the final image. It's now going to create a thumbnail for the web, which you can disable because it takes a few seconds for each image. Plate solves it, puts the world coordinate system into the final fits image along with a lot of other stuff, and that's it. We're done. End of run. Let's take a look at the log file, which will help us see what all went on during this. Again, my documents, ACP Astronomy, logs, today's date, the 15th, and it will be this last one, 6/11, yep, after 6. So, yeah, I want to, okay, so there it is. Now, let me switch my sources to Notepad++ and get this thing up here where you can really see it. Okay, now I've got a real video scene for this. Now I can also see the chat. That's good. All right, here's what all went on during the process, and I'm not going to get into all the millions of details here because this is really a thing about how to astro-image, not how the blood and guts of how the thing works internally. But you can see a lot of info is being logged here. This is primarily useful for me to diagnose problems. Oh, what do you mean? Pause and you know what? I didn't connect the rotator. Now, here you go. Warning at line 3, position angle given, but no, the system has no rotator. Son of a gun. I didn't connect the rotator. So I'm going to go back here and look at ACP and connect the rotator. Boom. Now I have a raw light, and son of a gun, I have a rotator now. So that was my error, and this was a good thing that I got to show you. So now let's go back over here to look at the log. All right, the rest of the log here, you can kind of see what it's doing. It's turns the tracking on, does a pointing update, measures the pointing error, which for this simulated telescope, there's not much pointing error. It's only 0.2 of an arc minute. Measures the focal length, blah, blah, blah. Tells you where in your observing plan you are, and they can be much more complicated than I just showed you. Takes the final image, does the plate solution on that, and turns it. I have the tracking. It says excessive pointing error, and I'll tell you exactly why that. We were working on something yesterday, and I was working on something yesterday, and what I had done, and I will turn this off, and so you can see there's a setting for that. Just top, boom, and go back over here, and yes. So pinpoint and all sky, maximum pointing error right here. That is the amount of pointing error you can stand. I'm going to turn that back up to 5 arc minutes because I have a wide field of view in the simulator. So that's why that got into the video. All right. I think I have given you a little bit of an idea of the basic operation of this, how it all works and what it's like to image locally with ACP. Now, there's information for astro-imagers here in ACP Help, and I always try to steer people to ACP Help on this, on everything, because after all these years, I have pretty much put everything in here that you could ever want to know about ACP, how to use it, how to set it up, tips on how to make things happen. It's, there's a heck of a lot here, and it is available. You can always find that right, not here. Where is it? Hello, there. Right here on the Help menu, Help, Contents, that's it. Okay, I've already got it open, so I'm not going to open it again. Now we'll go back here. All right. So first of all, this being about astrophotography, here is a section in here that says how, some simple things on how to do astrophotography. I will show you the web browser in a minute, but I want to point you to this as a guide. Now, when I get down here to multiple targets and timed events, I'm going to try to show you. The time is whizzing by here, and this even may be too ambitious, but I had a discussion recently with someone who just flat out images all night on one target. So they'll start at 30 degrees above the horizon, image all night, and quit the next morning at 30 degrees above the horizon on the other end. I said, well, what if you did 2 objects, an early one and a late one, and you just caught them from 60 to 60 and then 60 to 60? Well, yeah, but, it's too complicated or whatever. And anyway, I can put them in PixInsight, and the subframe selector will weight the bad ones lower than it will weight the good ones. Well, I still kind of wonder, well, why would you even put the bad ones in there if you can get 4 hours of good ones instead of 2 hour, a couple of hours of good ones and a couple of more hours of increasingly bad ones, and then weight the bad ones in, or take 2 hours of good ones of this, 2 hours of good ones of that, and go to the next night, take 2 hours of good ones of this and 2 more hours of that. Now you've got 4 hours of low air mass data on both objects. It didn't take you any more time, but man, it's too hard for me to figure out. I just want to get the job done. So I'm trying to encourage you with this to consider the concept of doing more than one target a night. And I have a mission on this one person to make him, not make him, but to encourage him and have him do it a couple times, and then he'll become a born-again multi-target imager. So that's really what this is all about, is to try to help you to be more productive and get things done. We'll go to the web browser in a minute, but that's the big message here. The other thing is the acquiring images automatically. We just finished doing a very simple observing plan, and there is all of the stuff about plans is here in ACP Help, acquiring images automatically, making observing plans. So I'm not going to go through all this, but there are all of these directives that you can put into a plan that will allow you to loop at 3 different levels, put weights in there so you can acquire some data, weights, and shift to another target, acquire some data there. You can loop around, do the whole plan multiple times, do groups of targets multiple times, or do filters within one target multiple times and shift between one to the next filter. So there's tons of things that you can do once you break out of the very basic observing process for each target. With an observing plan, you can really go to town, and this is why ACP is applicable to both science, all different kinds of science imaging, and to astro-imaging. So that, I would say, is something worth skim reading, and I will tell you the little story about how I survived as a computer programmer from when I was 17 till now, which is over 50 years. Every time I encounter a new system, I just take the manual and skim read it. Don't try to memorize anything. Don't try to learn anything. Skim read it. And just doing that, you'll kind of catalog some stuff will slide into your system or into your brain, and it'll just kind of be sitting back there in the dustbin. And then later on, while you're working, how the hell do I remember seeing something about this. Bam, you go back, pull out the manual, there it is, and you've got it. So just-in-time learning and skim reading for concepts. So I would say skim read here. Just kind of try to remember the stuff that's there. Don't even try to memorize it, okay? And the sample observing plans I'm going to spend a little more time on here, just to give you an idea. This was kind of here's some simple plans. The one we did is about as simple as it gets. Here's one, if you don't have filters, you could take images, a single 300-second images of 3 different targets, and it'll go to M5, it'll center it up exactly and take a 300 image. Then it'll go to M60 and take it, and M104 and take it. That's because interval carries from target to target. And if you go back here, these directives are organized into the ones that affect only the next target, the ones that carry forward from target to target, like count and interval and filter. So I could have added just another target to my plan, and it would have gone over there and take the image through that filter at that target. And then ones that affect the entire plan, either to repeat the entire plan or to set a condition for the whole plan or to set the time the plan will stop. So just so you know, that's where all that info is. Getting back to the samples, and I know I'm going fast, but I'm trying to cover a lot of ground here and trying to give you a more flexibility for doing your astro-imaging than you might have thought you had. If you come from CCD Commander or something that's really simple, there's much more here. Try to dig in and find out what's there. All right, so here's an example of one where we have 2 LRGB image sets and dusk and dawn flats and a shutdown at the end. So let's just take a look at that. Dusk flats means run off and do the flats at dusk time, and it'll start the flats process, wait till the right sky, take your flats and come back, and then wait until 0300 UTC. Okay, so because there's going to be a period of time after the flats can be taken, but before it's dark enough to take your actual images. So that's what that wait until is there for. One I can explain to you, but for now, just let that one go. Hello, Chuck. Hello, Ken. Hello, Joseph. Everybody's coming in here. This is really really good that we've got quite a few people in here, and I really appreciate you stopping by. I'm hoping you can get something out of this. The more the merrier here. So thank you again for joining us. So getting back to the plan here, the first thing it does is it says I'm going to take 10 images at 180 seconds each, binning of 2 in red. 15 images at 240 seconds with a binning of 1 in clear. So you get the idea here. Count, interval, binning, filter. Count, interval, binning, filter. So this now is set up to take 20, 35, 55 images and in rotation. Filter after filter after filter. Now, I might mention that once you install the software and measure the filter offsets, you don't focus between filters. ACP will shift the focus when it goes to the next filter, and that's the end of it. And it does work. I've had people not believe that it works, but then they try it and they go, yeah, it really does work. So it's important to get that set up. So we've done that for M5, taken all these images. Now we're going to wait until 0730 UTC, So it might just sit there, and then take a bunch of images of M60. Guess what? The interval binning and filter still are in effect. So the only thing I've changed is 15, 20, 15, and 30, but it's still 180, 240, 180, 240, 2, 1, 2, and 2, red, clear, green, and blue. And then when that's done, it's going to go dawn flats. Even if M60 finishes early, it'll fire up the dawn flats and it'll just sit there and wait for the skies to get right for the dawn sky flats. Take the dawn flats, and then it'll close the dome, disable the weather inputs, because most weather stations will say it's light out, so it's dangerous, the dome's closed, and ACP will see unsafe weather and it won't observe. But you can put this no weather in there, and that will allow you to do things with the imager and so forth, even though the weather's marked as unsafe. So this is when you would do your dawn calibration frames. And here we're going to do some darks and some biases. And when that's done, shut the system down. And that parks it, warms the cooler, and does all that stuff. So this would be a typical Astro-Imaging ACP plan. You can always come back and look at this. You can copy it right out of here, paste it into a notepad or a notepad++, and then make the changes. And that's it. Now, I need to mention that this M space 60 is enough for ACP to know the coordinates. This obviously is not going to work if you need guiding and you have an off-axis guider and you need to rotate the camera and figure out where the guide star is and all this other stuff. That isn't going to work. This would be for unguided imaging. Now, we're going to get into the guided stuff pretty much right now. So, well, no, I'm going to do one quick thing with the browser and show you how to get requests into the system without going through all this writing a plan and feeding it into ACP and loading acquire images and all this other stuff and having all those windows open. So there's another way, and for a lot of uses, if you can, stay up and switch targets in the middle interface. And what you see when you first log on is this and a welcome thing like that. Now you have some themes that you can select. I happen to like this, and it really works better over video. So that's about it. You just say, oh, hello there, or you can look at the getting started stuff here, which is semi-useful. And there's help info all over this this thing. For example, right here, the help button. Okay. So for live observing with ACP as opposed to schedule, we're not going to cover that tonight, and I apologize, but there's no way we're going to have time. I'm going to try to keep this under 45 minutes, and I'm not going to make it, I don't think. So we may be doing the ACP planner stuff next week or 2 weeks from now, which will be fine. So let's just go straight to the chase here. If you want to do a color series for your Astro-Imaging, it doesn't get much simpler than this. We could put in here the video and EBULA web. for a name. It doesn't matter. Oh, or we could pick a target by saying M space and get deep sky catalog search. M space starts with search. It says visible only, right? So let's go down here and pick one. So let's see where we'll say 57 is. How high is that? It says altitude 75 degrees. Great. So that's a good one. And if you'll notice, that deep sky catalog search put the coordinates right into the form. Boom. Now, if I had just typed M57 into here, and I knew that's what I wanted to do, let me close these checker dealies and hit get coordinates. Boom, there it is. Okay, so that's pretty cool. Pick the position angle, and then here we go. We're going to do 2 clears at 300 seconds, 2 reds, and I'm not going to go do much longer at 400. So that's going to take about 2 minutes. I have a choice of doing autofocus at the beginning. I can automatically calibrate. That requires that you have the proper calibration frames already loaded into Maxim's Cal Wizard. So just so you know. Dither, and then you can tell it to do dusk and dawn flats, and I won't go into all that. There's a way to set that up here, where you can set it up as a standard set of flats, and it'll just go do them. Or you can do one-time sky flats anytime you want. And if you have it set up for a panel, this won't say sky. It'll say one-time screen flats. So there, just so you know, the web interface changes with the configuration of the observatory automatically. It goes out and reads that, adjusts itself, and shows you reality about the observatory. So with that filled out, all you have to do now is push a button, acquire images. Boom. That's it. So let's go watch what happens. We don't need this form anymore. Go back here, and there it is. I will probably not let this run the whole time because we're going to chew up several minutes that I could be pressing on, but you get the idea here. I'm going to wait until it takes at least 1 image. Now, meanwhile, while this is going on, I have ACP and Maxim running like this. Desktop, top, boom. And that's the browser in the background there. So there it is. What am I doing? Oh, it's rotating right now. I put the rotator in there, so that should be done pretty quick. Here we go. All right. And you can see it said focus change of 10 steps, so it does the focus offsets. Right now, I think it's taking a pointing exposure. Boom, yep. And so this may look similar to what we saw earlier. It's just cranking along. It's going to do these images now automatically and deliver the results, though, via the web browser here. Back here to the same log that you saw in the console, but it's being updated here every 6 seconds. Again, you can see up here with this thermometer, it's going at a 10 times rate. Target M57, 1 of 2 filters, 1 of 2 for this filter. So it's telling you what the structure of your plan is and where it is in the plan. Weather, the PA, that's the sky PA. That has nothing to do with the rotator mechanical angle, by the way. And the German equatorial and the air mass, in case you're a science guy, that may be interesting to you, what binning is and what filter. And the cooler on the camera, which you can change if you wish. You can click this button, and it'll ask you for the new cooler temperature. Okay, so you can do that. You can disconnect the weather. You can do all kinds of things. Yeah, I didn't give it a number, so that's not a number. Okay, so anyway, this is the other way to use ACP. I'm using it as though I remoted into the observatory and typed 127.001 in or used the Use Web Browser button. I will get into remote observing in another video because trying to explain the difference is too crazy for this. But the point is, even if you remote in and you're used to using ACP, the console, you can push the a use web browser button, and then here you get the web browser right there, and you can use this instead of Notepad, feeding it into ACP, loading acquire images, starting it there, and all of that. So, and you know, you don't have to write a plan. This form, this thing here, whoop, I gotta go in here. I always do this. That thing is what wrote the plan, this form. And if I go in and look at my, I'm going to let this go for a minute and open up a file browser now and look locally on the machine here. File Explorer, there we go. Go to My Documents, ACP Astronomy Plans. This plan that is called Last Plan from Web right here. You can see it was done at 6:35. If I open this in Notepad++, now I have an observing plan that was created by the web form. And guess what? Here it is. So you don't have to write the plan. You can use the web system for writing the plan, and you can do this from a, you can even do this from a bullet train. And I'm going to show you that right now, which is really cool while this runs. Okay, right here. Paul Gardner sent this to me. This is him on a bullet train in Japan running the Great Basin Observatory through his iPhone. So I think that's right, is it? Yeah. Does it look like an iPhone? I don't know. Maybe it's an Android phone, huh? Because there's no button on the bottom. Anyway, whatever it is, yeah, maybe. I don't know. Anyway, it doesn't matter. It'll work with any of them. So I thought this was really cool when he sent that to me. And he of course, it's night there. So, and you can see right there on the, now actually, if you turn that phone sideways, it's a hell of a lot easier to see, of course, but there it is. So I thought that was pretty cool. So let's see where we are on our magic observing plan. I may kill it, and then we'll just go look at it. Oh, it ran. Okay, so we're done. And so now, since we are in the observatory, just like with the real ACP, we can go to, how do I get all these windows open here? All right, let's see. I need to File Explorer. There we go. My Documents, ACP Astronomy, Images, Video Nebula, Red. Oh, that's the single one we took. Which one was it? It was today, the 15th. Here's our pointing exposures. And the other one, what did I do here? I'm not going to hunt for this for much longer. I don't know where the rest of them went, and I'm sorry about that. But it did run, and it did produce images, so we can go look at the logs for today. And there's a big one here. And that one is the log for the Astro-Image that we did. M57. I don't know. That was what it was. I forgot that I used it. M57 as the name for it. We're going to go back and we're going to find it. All right. We'll go back to the File Explorer again. M57. Here we go. We did 2 clears and 2 reds. There they are. Okay. And I need to point out that the file naming and folder structure is totally customizable on ACP. And you could do anything you could ever want. And that's for another video. So now I had brushed over the internal guiders, and having done that, let me get this back. I wish I could really do the switching more efficiently here. All right, Chrome again. I need to force this to go to that. All right. Okay. Actually, what I'll do is start this video and make it save full screen. In this video, we'll use the SkyX to compose an image for a rotated internal or off-axis guider, then use the three coordinates, RA, dec, and position angle, to take a single image with ACP. We're going to image M33, so we'll locate it, then click the frame button to display the field of view indicator. Zoom in a little for a more precise view. This looks like a good guide star. Let's check. Mag 9. OK. For simplicity, we're just taking a single image. Using the three coordinates we read off the SkyX. As usual, here's the generated observing plan. And that's it. Imaging and guiding will be handled automatically by ACP. If your field of view indicator is scaled properly, and you choose a guide star that's bright enough, you'll get guiding automatically 100% of the time. All right, so that is, shut up. Let me get this shut off here, get it killed. All right. So that's the story on rotated guiding. I hope that just that itself gave you the idea of how to do this. All I can tell you is that it's the most complex to set up and the most complex to use, rotated guiding. But it's used by a lot of astroimagers, of course. Probably most of you have that kind of a setup. And there is help in ACP on this that I want to point out to you that's really, you should be able to, you should take a look at this. I'm not sure. It really is helpful. Let me get this put up here, ACP help. All right. Off-axis guiding field of view indicators. This section has some really good stuff in it. At least I think so, since I wrote it. But one of the most difficult things is getting the field of view indicator right. Now, yes, if you had the old SBIG cameras with the internal guide chip, or if you have some of the cameras that have the pick-off mirror that's part of the filter wheel, so it's always in exactly the same place no matter what, then it's easy because you can just pick that stuff in the sky and it automatically constructs it with the scaling that you need. But if you have an off-axis guider and like a Moog or something like that, you can turn it and you can put your camera in at some crazy angle, and the focal length could change based on how much tubes or back focus you have, and it can shift around. So you have to measure where the little guide sensor is with respect to the main thing. You have to measure it. And trying to do that manually is an exercise in craziness. So, how to set up a properly scaled field of view indicator the easy way. I'm not going to go through this, but this, using ACP and using plans and using the nudge key, you can get there in a tiny fraction of the time that I've watched people. I watched one guy one night he says, no, I want to do it. I know how to do this. And an hour and a half later, we were still trying to get it centered right. And, oh, it didn't work. I moved it the wrong way, or, this is really something to know. It's something that's specific to people who astro-image. Science people don't use rotated off-axis guiders, but so this can save your bacon. And here's the other one. How to win the fight with off-axis guiders. Get a guide star the easy way. Now, you say, well, I just use ACP or ACP Planner or Plan Capture and grab it. Well, that's good. But sometimes you just need to get a guide star into the guider. So, for example, you want to calibrate the guider. How do you put a guide star into the guider? Do you go to a place in the sky and then start nudging left and nudging right? And then you go, is this star bright enough? Well, it's kind of faint. Where shall I go? So in a half hour later, you're still hunting for, 15, 20 minutes later, you're still hunting for a guide star. Yeah. This will tell you how to win the fight and get that guide star on there at any position angle in 2 minutes. In literally 2 minutes. As long as it takes you to turn it, pick off the 3 coordinates, run the plan, which of course you can do through the web browser without even writing an observing plan. And then as soon as it starts the guider, you kill it in the ACP console. Boom, it's sitting there with a guide star right there for you. And I will point out that when you turn the tracking, when a plan gets killed in ACP, there's a track light here that you can see it coming on and off. I got to click it over here, of course. That light, I know it's hard to see, but maybe if you can zoom in or whatever, make your thing full screen. When an observing plan ends or is killed, or you kill the run with the abort button, that track light will sit there and flash. When it's flashing, it's saying, I'm leaving the tracking on for 10 minutes. If you need the tracking to stay on longer than that, you just click the flashing light and it'll leave the tracking on the rest of the night. So that's for engineering work, for adjusting stuff and so forth. So that, otherwise, if you had run an observing plan and started the guider and killed it, the tracking would be shut off, and then, which it always does, and then poof, the guide star is gone. So that's what that's for. And it automatically stays on for 10 minutes. So to run a plan and kill it, it'll still be tracking. Your guide star will still be in the guide chip, and you can then go click that button and then go calibrate the guider. So that's what that's there for. That's just a little tip on stuff. So I've explained that. We're at 6:45. That is about how long I wanted this to go, was 45 minutes. So next time, in 2 weeks, I'm going to cover ACP Planner and probably cover it in more detail than I had planned tonight. So that'll be good. And using Planner when you're remote, not always having to log in and run the sky on the observatory machine. You can run the sky at home and have your observatory be somewhere else and run the planner at home with the sky, figure out your plan, produce an observing plan, and Planner will automatically push it to the observatory into the plans directory. Then guess what? If you must and log in with a remote desktop or whatever team viewer, you can go in there and run it the old-fashioned way with the console. That plan will be right there in the My Documents, ACP Astronomy Plans directory. And you find it, launch it with the old-fashioned way with the console, or you can go on the web browser. It does indeed have a way to look at plans and start them. The browser itself, and that is Multiple Objects Plan here. Click, and then what do you see here? Instead of a form, you see a way to get to all the plans that are on your system. So if you have prepared a plan at home with the sky at home and use the planner to push it to the remote observatory, or if you prepared it on the observatory and you want to run it, you still don't have to go to ACP, load acquire images, then hit run, and then go pick the plan like that. You can just use the web browser and pick the plan here, press acquire images, and it even supports folders into which you can organize the plans. So, and that whole browsing thing is part of the ACP web interface. So with that, I'm going to wrap it up for tonight. Thank you, everybody, whoever showed up. And I'm hoping that those of you who view this afterwards will also benefit from it. I need to go back to my little checklist. That's right. On the Comm Center, on our DC3 Dreams Communications Center, there is a thank you, Chuck. I appreciate the kind words. There is on the Comm Center a suggestion box for DC3 Dreams Live TV. I put that in there this week. So far, no one has bitten on this, but if you have questions, or if you have questions that came up during one of the live broadcasts and you want to, okay, can I see your question? And I will definitely answer it right now. Just a sec. If you have questions after the fact, or you like it, whatever, get on and use this suggestion box. It's in the public section of the Comm Center, so you don't need even to be a paying customer. You can be anybody. And if you don't have a Comm Center account, you can contact Stephanie. She'll make you one. But we don't just have open enrollment for obvious reasons. So if you want, you can post compliments, questions, and everything in this thread. It's open, and I would appreciate knowing what you guys are looking for. Ken, a variety of weather stations. To answer your question very quickly, to go back to ACP Help, you can go here, ACP Help, Weather Safety. All right, and you go down through here, and there they are. Boltwood Cloud Sensor 2, the old Boltwood, which I hate, but it worked. You know, I still have people with them. AAG Cloud Watcher, Aurora Sensor, and I also have made one up for Sierra Remote, which has a special setup so that the open and closed roof is what's interpreted by ACP as weather safe and unsafe. And that's even more important for the scheduler. So if in the middle of the night the roof opens up, the scheduler will fire everything back up, pick the appropriate target, and start observing again. So, and I've done these special servers for other people. I did one for the Brisbane Girls School with a special thing, and we just did one last week for somebody who has a weird setup that the cloud sensing part is what determines whether the roof is open and closed, not the alert. So it's some different type of weather system, but it was a variation of one we already had, and I'm happy to help people. So a lot of different, to answer your question, a lot of different kinds of weather servers are supported. So now it is time for me to say adieu, and please subscribe. Again, I'm not going to put that thing up there again, but just please do subscribe to the channel and hit that bell icon, and tell your friends and all of that. And good night. Thank you very much.